Everyone. Welcome back to another lesson in MCR3U. Today we'll be talking about rational exponents. And so here to start, we see here that we have a to the power of 1 over n. We can rewrite it as the nth root of a. And so here, let me just write that down. So here we can write it as the nth root of a. A good example of this is if we have a to the power of 1 over 2. Here we see that it is square root of a. And so a to the power 1 over 2 is equal to square root of a. So here we see that if it's a to the power of m over n, so m over n, then we have the nth root of a to the power of m. Or we can rewrite it as nth root of a with the brackets to the power of m. So here it tells us to simplify the following rational expressions. And so here we have 16 over 81 to the power of 1 over 4. So here we can rewrite this as the fourth root of 16 over 81. And here we see that 2 to the power of 4 is equal to 16, and 3 to the power of 4 is equal to 81. So here we see that our final answer will be 2 over 3. Again, remember the root applies to both the 16 and to the 81. Another way we can think about this is if we rewrite it as 2 to the power 4, 2 to the power 4 to the power of 1 over 4 over 3 to the power of 4 to the power of 1 over 4. And so if we're using our exponent rules, 4 times 1 over 4 would just be equal to 1. So we really can write it as 2 to the power of 1, so 2 to the power of 1 over 3 to the power of 1, which also will give us 2 over 3. Here we have negative 16 to the power of 1 over 4. So here we can rewrite it as the fourth root of negative 16. Here we see again that we cannot square root a negative, so here this does not exist. Here if we have negative 32 to the power of 1 over 5, rewrite this as fifth root of negative 32. Here, this is what is different than the value of negative 16. Here we can rewrite this as negative 2 to the power of 5 to the power of 1 over 5. And that will give us a value of negative 2. So in this situation, it does exist here. And for D, we have negative 27 to the power of negative 1 over 3. And so here we can rewrite the negative exponent as a positive exponent in the denominator. So we'll rewrite it as 1 over negative 27 to the power of 1 over 3. And rewrite that as 1 over cube root of negative 27. And so the cube root of negative 27 is equal to negative 3. So here our final answer is 1 over negative 3 or negative 1 over 3. So here now we're going to solve the following expressions here. So here we have x squared is equal to negative 16. Again, to get rid of the square, we're going to square root both sides. Here we get x is equal to square root of negative 16. And here x again does not exist in negative 16, so there's no solution. Here we get x squared is equal to 16, so we'll do the same thing as we just did. We'll square root both sides. Here we get x is equal to plus or minus 4. So remember, it can be plus or minus in these situations because when we're solving for this equation, again, x could be negative 4 times negative 4, which will give us 16, or it could be 4 times 4, which is equal to 16. And when you're solving equations, you don't know which one it is, so you have to provide both answers. Here first, this should be C. So here we have x cubed is equal to negative 64. So to get rid of this, just like how we square root both sides when it's squared, here we're going to cube root both sides when it's a cubic. So here we can rewrite this as x again is equal to cubed root of negative 64, and that will give us an answer of negative 4. This last one, which is d here. So x to the power of 4 is equal to 10,000. So here, fourth root both sides to get rid of the power of 4. So here we'll get x is equal to plus or minus 10. And then here it tells us to simplify the following rational expressions. And so if you recall, we can, if we write x to the power of a, x to the power of, no, a to the power of m over n, we can rewrite it as n root a to the power of m, or as well, nth root of a to the power of m, like that as well. So let's look at this. So we have 8 to the power of 2 over 3. We can rewrite this as cubed root of 8 to the power of 2. The cubed root of 8 is 2, and 2 squared is equal to 4. Here we have 81 to the power of 5 over 4. So here we can rewrite it as the fourth root of 81 to the power of 5. Fourth root of 81 is equal to 3 to the power of 5. And so here, in case there's any confusion, again, because we're not solving for the equation here, we're just going to assume here, again, that it's the positive value of 3, and we won't consider the plus or minus. So here we have 3 to the power 5, which will be equal to 243. And here we have 49 over 81 to the power of negative 3 over 2. And here we're going to make it into a positive exponent. So we're going to flip the numerator denominator. So here that will give us 80. So we can rewrite it as 81 over 49 to the uh, to the exponent of 3 over 2. So positive. Here we can rewrite this as square root 81 over 49 to the power of 3. Square root 81 is 9. Square root 49 is 7. So here we'll get 9 over 7 to the power of 3, which would equal to 729. 729 over 340. Here we're going to simplify and express our answers using only positive exponents. So here, first thing we'll do is we'll multiply the two exponents together. So here, x to the power of 2 over 3 times x to the power of 2 over 3. That'll give us x to the power of 4 over 3. Remember, we're adding the exponents when we're multiplying with the same base. At the bottom here, we still have x to the power of 1 over 3. So here, when we're dividing powers with the same base, we have x to the power of 4 over 3 minus 1 over 3, which will be equal to x to the power of 2 over 3. Or sorry, x to the power of, so it'll be x to the power of 3 over 3, which will be equal to just x here. Here we have 5x to the power of 1 over 2 to the power of 2 times 4x to the power of negative 1 over 2. Here we'll distribute the 2 into both into the 5 and into the x to the power of 1 over 2. Here we can rewrite this as 5 to the power of 2 and x to the power of 1 times 4x to the power of negative 1 over 2. Here, if we multiply the coefficients, so 5 squared times 4, or 25 times 4, that's 100. X to the power of 1 times x to the power of negative 1 over 2, or 1 plus negative 1 over 2, x to the power of 1 over 2. So here we can rewrite it as 100 square root x. Here it tells us to express the following as exponential expressions. So 5, 5 root 5. And here, again, if there's no exponent, we assume that it's 1. So here we can rewrite it as 5 to the power of 1 over 5. Here, 6 root 7 to the power of 3. And rewrite that as 7 and 3 over 6. And simplify 3 over 6 to 1 over 2. Here it says express fourth root 10,000 m to the power of 8 as expression with exponents, then evaluate. So here we can rewrite this as 10,000 m to the power of 8 to the power of 1 over 4. We can rewrite 10,000 as 10 to the power of 4 and m to the power of 8 to the power of 1 over 4. And so we'll multiply, or we'll apply the exponent into 10 to the power of 4 and m to the power of 8. 10 to the power of 4 to the power of 1 over 4. We're multiplying the exponents, which will just give us 1. So 10 to the power of 1 is just 10. M to the power of 8 times 1 over 4. So it'll be 8 over 4, which will give us m to the power of 2. And just a challenge question to end off here. So we have square root of square root of square root of m to the power of 8. So here we can rewrite this as square root m to the power of 8 over 2, which is equal to square root m to the power of 4. And we can rewrite that again as square root m to the power of 4 over 2 is equal to square root m to the power of 2, which will give us just m by itself. And here are just some of the exponent rules to help us in terms of these types of questions.